Yeah.
Sorry about the 10 minutes you lost. So let me go straight to business then. I've sent you the mirror link on the chat now. I think you can post comments in the slides itself. So as you have questions, try it out. But if not, please put it on the chat. I can see on the chat some friends of mine. So hi to you. Thanks so much for joining. It's always good to see you here. So when we talk about monolith to microservices, right? I think the first challenge we have is actually to extract data out of the monolith. So let's start with that. The story that I'm going to tell here is about GetFeedback.com, which is it's a product by Momentive, which used to be SurveyMonkey in the past. And I had the pleasure to join there when there was already the beginning of a journey to get away from the monolith. Reasons aside, that's not the objective of this talk, but some of them to improve autonomy of the teams and make sure we could keep introducing features with less friction. So when I got in there, like we were starting to build the first microservices, and the first challenge is like, hey, how can I start interacting with that data that only exists on the monolith at this point? So the data extraction or data linking or syncing is the first problem to solve. So the first thing that I see was that we had a service starting to being built up, and then it was going to the database of the monolith application and doing like a select star from table X. So this was already a point of attention, right? Because what happens in this situation is that we are polling the data, and this already presents some data complexity, because first, if you wanted to extract the data out and you have a huge delay because you're doing select stars and then you're looking for, let's say, last modified at columns or things like that, that creates overhead in first place. That creates a huge lag for you to take the data out of the original system, of the source system. And on top of that, you might miss deletions or quick updates, right? So let's say a row is inserted on a table and then I quickly update it. If my fetching, if my polling of the data is not quick enough, I might lose that in-between transition state. And the same for deletions as well. If I create something and then I delete. So the polling is not really optimal if you want to keep things in sync, especially if you want to have a historical trade of it. So that was the first issue. And in theory, like what we would love to have is, of course, move from later, like after the data is in the new service, we want to have like some level of routing so we can start bouncing the requests between the services, right? Old service and new services, so you can start testing it. So the first thing we built as platform, so I'm going to jump right into it, like what kind of work the platform could do in those cases. We introduced a different way to extract data from those microservices. What we decided to do was to look inside of the database transaction log and start extracting it. So what does that mean? It means that we could leverage on the same way that the databases do their own replica set, and leverage on this way to now start inputting data for our microservices. So what is that? That technique is called change data capture. And change data capture is what it means. Like I want to look out for changes in my source database. The DB transaction log here that I mean, in MySQL, it means it's called bin log. For Postgres, it's called wall log, which is write ahead log. For Mongo, there is like an oplog table. Each database has its own thing, but in general, that's a technique which can give you not just fast, but also high quality data, because you now, instead of like polling that data on select everything, I can start monitoring those changes. So as soon as a row is inserted and updated, deleted, the database transaction log needs that to create its own replicas. And the cool thing about this log is that it's also full with important characteristics of data. So it has an atomic message because it also caters for idempotency and repetition. So what it means is, instead of having like on the transaction log, instead of having, let's say, update column A to value B in case if the, let's say, whatever criteria match you have, this is a change. This is an operation that can change many rows. And if I execute that same SQL query, I'm not going to get the same results because I'm already going to have changed something on my database, right? It's a stateful operation. So the write-ahead log, the transaction log, it's meant with, it's going to basically split those transactions into smaller ones or even with a different syntax. So we always can repeat those things. So what it means is like any transaction log that I repeat on my database, it's always going to come with the same outcome. So that's idempotency by default. And those are great characteristics if you want to have a strong data pipeline and microservices based on data in our platform. So we basically started monitoring those transaction logs and pushing this data to Kafka. Now, how can a platform team actually help with this process? We made this process a self-service model. So basically, we understood that many of the new microservices that were going to be developed and created by the teams, they needed to start by interacting and fetching data from this monolith. So we gave them a way to basically, in configuration, go and say like, hey, I'm microservice A, and I want to start monitoring for tables A, B, and C. Once that happened, the platform itself would already provision a new worker for that demand, would make sure it was centrally monitored. So like every time a new table was being monitored from the legacy system, from the monolith system, we were able to generate all the runtime, all the infrastructure, all the monitoring and everything to make it happen. This is an example configuration, but like tables to capture A, B, and C. Of course, the real configuration is a bit more difficult, but that's the idea that like centrally the platform team could already start offering this as a service, right? And then this was done in a central repository for us. But I would say if we were doing it today, we would likely look for a way to do it closer to the microservices themselves. So basically creating this configuration inside of the microservices Git repo. In Kubernetes, you could achieve that, for instance, by having a custom resource definitions and then saying like, hey, this configuration now lives for this microservice, and then this microservice tells me which tables they want to monitor from it wants to monitor from the monolith system, for instance. This would be an option. Now, what are the advantages of having this model here instead of the polling model? Is that now we have near real-time and consistent data flowing through the system. So this is very good data to empower not just the microservices, but like you can empower new features, you can empower data lakes and data migrations and many other things. You can empower your cache if you want to, and etc. So CDC is a very interesting concept to look at. And then basically the path chosen here was to have a Strangler pattern. I've put a link here in the deck that you folks can take a look later. But basically that idea of having a router in front of the infrastructure, in front of the web servers, syncing the data hidden from it, and then being able to serve those reads from a different service. That's a very interesting concept because many times our initial thinking of how to communicate between a monolith to a microservice could be, hey, I'm just going to make the same request to both services. But that is fail prone, right? Because we would depend on both services to answer the same, like one of them would have to answer correctly to the user. And then it's very hard decision like, hey, do I wait for both of them to answer correctly before I send the response back to my user, yes or no? And then how is the data consistency in this process? What if the monolith service returns 200, but the new microservice doesn't? What do I do? And on top of that, when you do this, you're forcing your new service to comply with the payload of your monolith. So it becomes kind of a very shallow copy of the monolith. And in this case, if we are having the opportunity to extract a service out of a monolith, maybe it's also a good opportunity for us to think about the data model and actually question it. So that's why we also chose the Strangler pattern with message-based systems in this case. I'm not going to get in a lot of details about change data capture and etc., but the platform team was able to provide this as a service, which was basically the first architecture service we provided. And by the way, if it's not being clear something, please post on the chat, and I'll happily, I have the chat here on my eyes, and I'll happily clarify something. So yes, then now all the services can start having their data synced and everything. And then a second problem started to create, right? As your microservices start to become source of truth for some data, because that's the objective, right? I extract the functionality out of my monolith. I'm able to replicate the most crucial features. But from this point on now, I have the source of truth, which means I want to expand and I want to enhance that microservice. In this case, okay, microservices now have to start publishing messages to our message broker. So if we think of a simple way to solve this problem, which is very common, we do that for queues, we do that for when we have to store to multiple databases, or when we have to, let's say, do a database insert, and then I have to call an API right after. I can just do that, right? So let's pretend service A does its thing, receives the request, processes the data, writes to the database, and then it makes a call to the message broker to send that event. From a first perspective, it looks like an okay operation. However, this is a problem that has a name. It's called the dual writes problem. And why is that? Because if those two things are not in the same transaction, and I actually write the data to the database, and then I try to send to my message queue or to my message broker, what if the message broker rejects that message? Am I rolling back the database transaction? A lot of times we don't do that, right? Like we can see that some people think of that, some people don't. So basically you could keep this transaction open while you send the message to your broker. Once you get confirmation, you commit to the database. But at the same time, if your message broker doesn't support transactions, what it means is you might still be able to publish the message to the broker and fail to commit back on the database, right? So it's not a safe operation, because unless both systems support a protocol like two-phase commits, for instance, any other distributed transaction, you might get into a fail state. So there's a very common problem. It's invisible. I even put a link here, which is Dual Writes, the Unknown Cause of Data Inconsistencies by Torben. I don't know how to say your name, I'm sorry. But it's very interesting read to do as well. But in sum, okay, we saw this problem, like as platform. We have multiple microservices that have to produce data to the message broker. And we might be encountering data inconsistency here, because I cannot, in our case, we were not using two-phase commits for this usage. And even if we did, you might incur other problems like long-running transactions or rollbacks, which are very difficult in some of the storages. So we wanted to get to a place where we could do those things a bit more safely. So I'm going to talk to you about the Outbox pattern. So let me just go to my next part here. So the Outbox pattern, it works like this. Let's say you have your microservice again, and then you make an operation, right? You want to start to write into your data, to your tables in your database. In the same transaction that you do that, you're going to write an event, a message, to another table in your database. And that table is going to be called Outbox. So basically, so far, the data hasn't come out of the database. However, I was able to shape an event that has all the characteristics that I want to propagate to my message broker. So in here, it could be like, hey, yes, the payment is processed correctly. Now I want to send a message. So like the shipment service can pick it up, right? Like it's an asynchronous process because the payment happened not synchronously. Okay, so right now I can write that message to my database as well. And here we get to a different situation. We get to a situation of all or nothing. So in here, I don't have the risk of writing only to the Outbox or only to my domain model tables. I write to both or write to none, and that's guaranteed by the database transaction system. So that's a very nice outcome. So the question that comes later is, okay, how do I take this data out of my Outbox table and then move it to somewhere else? And for that, we use the transactional Outbox relay pattern, which basically what it does is now we're going to use the same approach we used on the first use case here, which is to use change data capture. And this time we are going to be monitoring for inserts inside of this Outbox table. With this now, like I have a tiny delay, I need to read from that transaction log and push it to my message broker. But now I again achieve 100% data consistency because I have a pointer in my transaction log on the database. My message relay is monitoring those cursors and those IDs inside of the transaction logs and then publishing it to my message broker. Now, if I can't push it to the message broker, I simply don't move on my cursor inside of the replication slot, in this case, the transaction log. This is very useful because now I have a fully data consistent way. And if you design your message as well inside of the Outbox, the same way, let's say, a transaction log of the database does it, duplications are not going to be a problem. So that's it's kind of a side message here is once you are in a message-based architecture, you really want to cater for idempotency of your event. So shaping that is a crucial part. We could have a whole talk about how to shape messages in your architecture and how to make it in a way that survives duplication, survives retries, and etc. But in this case, like, yes, we can take the message out of the Outbox and then push it to the message relay with 100% data consistency. So we saw that could be a very good use case for us. And because we already had a lot of experience in managing our first platform service with the monolith data extraction, we eventually called the project Legacy Data Syncer, which was not a good choice because it was not really legacy. But we now had the expertise of managing the infrastructure of a change data capture. So this kind of fit like a glove that our second platform service would really like be an add-on to those microservices to safely produce data. Let me read the message here. Does an Outbox pattern imply that there must be a transaction over platform schema and services schema? What if it's a different machine? I'm not sure if I fully follow your question, but in here, the schemas will be on the same database. That's extremely important. And they have to be in the same transaction. The Outbox table, it doesn't necessarily have the columns and fields of your event. In here, you actually have like an ID of the event itself. So you can have unique event IDs for also the duplication and idempotency. But the payload of the event could be just a JSON, could be just a binary. For all that matters for the change data capture, it could be a binary, it could be just a string, so it doesn't care about the contents of the payload. Not at this point in time though, but it's important they are on the same database in the same transaction. And you can have tooling from the platform engineering team to provision those schemas with the right permission. So let's say it can automatically make this microservice only have inserts permission within the Outbox table, and the rest of the schema is managed by the platform team. That's a way as well to keep standards. And please keep asking questions if you get through it. Okay, so I see some interest in the Outbox pattern. So yes, you can delete the data from the Outbox table for sure. It can be kept for a little while if you want to do some level of disaster recovery plan. Let's say if you made a mistake in your message content, not really the schema, right? Because the schema is easy to validate, but let's say you had an enum and then you put the wrong thing in there. You cause a change which is not seen by schemas. You can still try to recreate those messages, like by doing a select insert, basically, in the Outbox table. That's one option. We have done that in the past. So could be a good practice to, at least while you are really getting the hang of how to publish message as well, to keep a few weeks or months of storage of your Outbox table. But even if you, in the same transaction here, if you do, let's say, insert on your business schema table and on the Outbox table and delete the row after inserting it, you're still going to achieve consistent results because the transaction log is going to have all of those operations and then you can still push them forwards to your message broker. One thing to remember here is like Kafka is a durable system. So messages are persisted in disk, and you can actually have guarantees for that. Like you can say like, hey, I want an acknowledgement of Kafka only after I have, let's say, 3 brokers with a copy of my message. This is the kind of things you can do in Kafka. But if you're not dealing with a durable message broker, you can choose to keep your Outbox messages for longer. So with this, we really achieved this very, very fast standardized way to publish messages from the microservices. And the cool thing is like, yes, you just have another configuration file that says like, hey, I need to publish messages as Outbox. And even on the code side, it's much simpler because now microservices don't have to have Kafka clients or RabbitMQ clients or whatever. They already have the database driver. They just write it. Later, I'm going to talk about like how the platform team also helps to make this easier to use in the application itself. So this was a very interesting pattern. We reused the change data capture, which was very, very nice. So we could have this high throughput inserts and very little logic on the application side. On the other hand, we started to create the inbox. This was not fully done after I left GetFeedback. So maybe someone who still works there can answer this message. But this is also about a different pattern, which became very important at the microservices, the event-based microservices architecture. Once your services, let me just go back here to the initial one here, so it's simpler. Let's say I was able to move the data here from one side to the other, right? So let's say I copied here all my users from monolith now to the microservices. Once you copy this data in the new microservices database, you achieve something. You achieve an autonomous service. Because if this here was actually a HTTP request, like, let's see if I can add it. Yeah. If this here was an HTTP request and I was like, hey, oh, I received a request on my new microservice. Now I go and ping the monolith. If the monolith is out, is having any sort of trouble or like is unstable in any sorts, you now just sacrificed the reliability of your new microservices as well. So the whole point of this architecture as well was to achieve autonomous microservices. And to do that, a lot of data copying was necessary. One very important trade-off of this is that, like, yes, you have a lot of duplicated data in your platform. You're certainly going to have like multiple copies of the same data, but we can talk about it later. But the point here is like, if I need, let's say, information from another service to make a decision on my microservice. So let's say I own the payment system here, but I still need to use the user's information, right? The address, for instance, from another, like from the account manager system. So which means I want to have that data in my microservice so I don't have to ping them when I have to make a transaction. So I can keep processing payments even if my registration form is offline, which could be a good use case because now we are increasing the reliability of the infrastructure as a whole. So instead of pinging that microservice every time that I need an address, I'm going to copy all the addresses to my database. There are many other points to this, but like one of them is, yes, I become autonomous because now I can look at my own database where I have the addresses and I have the data that I need to process X functionality, and I can autonomously answer the requests of my users. So I was able to fulfill the request without having to ping any other service, and that's very nice. Another added advantage to this pattern is that I can shape the data of my microservice, like of that projection. We call this a data projection in my microservice. I can shape this data for my read patterns. Because what happens a lot of time is like the service that is writing the data not necessarily has the fastest read model. It might have a good write model because that's its focus, right? It's to mutate the data transactionally safe and provide the necessary information for my user. Now, I can actually reshape the data. So instead of, let's say, instead of looking for user ID, I don't have user ID on this request here. I need the email. So I can make my primary key the email, for instance, on my projection. So those changes are possible and they are very useful. You can invert many lookups as if it's your specialized cache for this thing. Of course, it introduces eventual consistency, but we can talk a bit more about that as well. So this pattern also started to emerge. This pattern was initially like every microservice would have like a Kafka consumer, and they would consume those messages from Kafka themselves and then save it to the database and then being able to receive requests. But like, why should every microservice now write Kafka consumers so they can fulfill their database if we can offer that same functionality as platform? A common theme here is like, yeah, platform engineering teams, we are looking out for the quick wins, which is like, hey, people are repeating the same code in multiple places. We should totally try to come up with a way to solve this problem. And as an add-on, when we were doing that, we were always trying to deliver something better, right? People are asking for automated projections, but we are going to give them automated projections with, I don't know, the duplication embed into it, with like good absurds, with options to mutate the schema, to mutate the data format, really adding a lot of value to those product teams that need that pattern in their service. So when we have both like inbox and outbox patterns in a single service, we start to get really in the land of eventual consistency, right? Like I really have to process messages, and messages can be late. They can be delayed for a few milliseconds, seconds, minutes, or in the case of an outage, could be hours. So this is classified as a base system. I'm not going to get into a lot of details here, but it means basically available. So the system it has the ability to still serve requests even when all the parts or even when the source of truth or parts of the data are not live, because we have that copy. It's soft state, which means my state can change here from requests, but also the state of my database might change in reaction to events being processed. And it's eventually consistent because those messages might come later. Eventual consistency is for sure one of the hardest problems to deal with conceptually. And that's where we spent a lot of time with people in the team to really understand the workloads, right? Because in first sight, everyone likes synchronous data because it's just easier, right? I don't have to think whether what I'm fetching is outdated or not, and whether that influences the decision of my microservice. But once you challenge this idea, you have the chance to come out with a much more reliable and stronger system behind. So just to wrap up this part, like the Outbox was also provided as a configuration to the microservices, and they could do that in a very simple way. The automated projection as well, like you would go create a configuration, say like, hey, I want to monitor topics or queues A, B, and C in the infrastructure, and they would be converted to tables. Later on the slides, you can read like the capabilities of like what kind of benefits they bring. So a final microservice like configuration, like this is not what we end up having, but let's say if we follow the pattern of having everything inside of a Git repo, you would have like, hey, hey platform, I need to outbox my table. I need projections from topics A, B, and C. This is the schema that I'm dealing with. And then as platform, we would read that configuration and automatically provision the infrastructure. Of course, Kubernetes is a very nice tool to do that, as it has native APIs for us to deal with custom resources like this. So it's a food for thought. If you want to see some of the screenshots on how this works, I also linked a tweet that I made a couple of years back about this topic. So let's get in the application itself. I'm still going to try to wrap this up in 5 minutes, maybe. Let's see. So when I have this outbox, and when I have the inbox, and when I have multiple schemas on my database, and when I wanted to standardize those use cases, eventually it really influences how we do the code inside of our microservices. So the platform work was not just like, hey, here is change data capture as a service for you. well, like, hey, this is how you could use this inside of your microservice. So how can I, for instance, hook the event system of my application? Or like, how can I say like, hey, make events become messages in the outbox within the same transaction? And how can I do that safely? So instead of every time I want to write something to my database, I have to call a special thing to also write it to the outbox, which is like developers error prone. Let's say if you operate a change, like you do let's say you have a model and then you have a repository there to do changes in your database. And then if you forget to include the Outbox table, you just caused the trouble, right? Now we have to backfill those events somehow. If ordering is a problem, how do we deal with that? So basically, we would also offer libraries to those microservices. Those libraries would embed the functionality needed to make this work. So like in the case of Outbox, you would dispatch an event like you would do normally in your service, but then this event would be captured by the framework. It would be put in the same transaction as the current transaction you have running in your ORM, for instance. This could be solved in different ways, depending on the language, depending on the tech stack. This could be monkey patching. This could be middlewares. This could be, I don't know, some dependency injection tricks, depending on your framework. So, but what is important is the platform team delivering a full experience, right? It's the experience of, here's a good pattern, how you solve the publishing messages problem. Here is how you use it inside of your microservice. Here is the infrastructure to monitor it, to alert on it. Here are the lag between the messages being sent and how long they're being processed. So those are many ways. And of course, like those microservices, as we get back like to the infrastructure itself. Sorry, if I look at this one here, for instance, like, yeah, those are going to be many boxes, and they have different combinations of like inbox, outbox, and these also are containerized applications. So you also have to talk to the infrastructure, right, to have a robust architecture. So those same microservices would also get from the platform team many libraries. So you would have like logs standardization, health checks and monitoring and custom metrics. The CI/CD configuration, we would also offer a standard Docker image for you to build on top of. So it's really a holistic experience that a platform team can offer to you. And each of those things, like, yes, they would have many, they are opinionated, and that's why they become effective out of the box. But also it's important to create flexibility for your users, right? So like not everyone is forced to adopt all of that, besides what will be like standard for the infrastructure. And this way you can really now not just have a safe way to publish messages, to sync your data, to do the, avoid distributed transactions as much as possible. You also really accelerate software development, because now I can do all of those things without having to worry. I have a default CI/CD, container, monitoring, health check, logs, ways of doing data migration, ways of serializing, deserializing requests, headers standards, tracing. Once you offer all of that out of the box, you really can accelerate software development. Sorry. Been talking too much. Okay, so let's move on. Like more patterns is starting to emerge, right? As we continued in this transition, like I'm resuming here like 4 or 5 years of transition. So this doesn't speak to all the work being done. And it was amazing work by the whole team. We had almost 20 people working exclusively on the platform engineering, plus other teams on different areas of the platform as well. So let's say services starting to emerge with different patterns. For instance, services that needed to do machine learning processing, like natural language processing, or any sort of like, I don't know, language detection or translation and etc. So new patterns are starting to emerge where microservices would fetch data from the message broker, again, Kafka in our case, and then start doing a serial of HTTP requests, for instance. This is very common because, like, yes, I have to integrate with third-party software, and a lot of times those are HTTP requests, or even I need data synchronously. So that's an exception to the eventual consistency, right? Let's say if the team agrees that, okay, no, this service really needs data live. It has to be in sync data. So they can query, they can make an HTTP request on other service. So this pattern of making HTTP requests and changing, mutating the data you have, your state, and then moving forward to the next message broker or the next topic or queue, whatever, really started to emerge. So the platform team created even another service for the teams, which we call the Kafka HTTP pipeline processor. It's a beautiful name. And what it did for us is adding a series of capabilities for this process, right? It would be an isolated service. This one was not a library or a pattern. It was actually a mostly configuration-based service where we would say like, hey, call API X, Y, and Z for me, mutate my payload the way I want to, and then I store that in the next queue, the next topic, and then the next microservice can pick it up. So really creating like data pipelines that are part of the architecture, not just like, because a lot of times when we hear like about data pipelines, we're thinking of extracting data and pushing to BigQuery or to any data warehouse or data lakes, etc. In this case, these are like data pipelines that serve the purpose of making the data in the architecture better, more reusable, robust, that allows for new use cases to emerge. For instance, if I want to introduce audit logs on my system, instead of like trying to find out how can I do that, I can consume all of those topics and then produce audit logs out of that, for instance. So you really enable new use cases that wouldn't be possible before. So we created this self-service service as well. And it had many other functionalities. For instance, you could filter messages. So let's say like, hey, I'm consuming a given topic, but I don't care about messages with a certain pattern. Then you can do filtering just by configuration using JMS path or regex kind of things. You could copy fields, you could drop fields, you could insert timestamps into the message. You could rename fields. And then later we even started like allowing you to route messages. Like a good example here was, I'm actually going to mention this one, like notifications architecture that emerged from this. I am monitoring, for instance, let's say payments, right? Or it's very common. If you go like to PayPal and then you change your address or your email address, you're going to receive an email saying like, hey, did you change this? Click here to do X. So we started hooking up on different systems to see what they are doing, because we know that all the data is in the message broker, right? So we have that confidence. So we could monitor those systems, and then we could decide based on a user configuration or a system business logic. Hey, I want to then send a email to this person, or I want to update my CRM, or I want to make a webhook call to whatever random HTTP call. So we also introduced not just the filtering, but also the multiplexing of those messages and routing as well. So you could, for instance, from one source event from another microservice, again, any given microservice in the architecture, I could consume their events, do some logic, and then I could say, oh, I actually want to send 3 notifications out of this. One that is going to go to the mobile app, one that is going to be sent as email, one which is going to be a webhook. So we could both do the multiplexing, but also routing. So different workers or different microservices could process that later, which means like if my email system is down, the topic of the email system gets clogged, but I don't interfere with my CRM integration, for instance. I don't interfere with my Slack integration and so on and so forth. So again, if you start seeing like, we really try to create a very fail-safe, autonomous microservice environment, right? So how does the final picture looks like from a platform team? As you get all of those use cases and all of those tools, every single one of those boxes were at least one functionality provided by the platform team with the intent of accelerating the software engineering, but also giving you like a safe way to process data and a safe way to deploy your microservices and etc. So besides those that I already showed to you, like the local data projection, Outbox Pattern, and etc., We had, for instance, end-to-end testing that could do an operation on the legacy system and see the outcome all the way into the new services. So that was also provided by the platform. We offer default CI/CD configuration and customizable pipelines in our GitLab in this case. The schema registry for the topics, the default configurations and patterns for your messages inside of the Kafka topics. What does this mean? Like, is my topic going to have mixed data types, or is it going to be event-based, or am I always going to have the latest version of each message? Do I need retention in time, or is this GDPR compliant, et cetera, et cetera? So we were able to offer all of those services, packed contract testing for synchronous API calls. So contract testing is like, hey, if a API wants to change its schema, you have an automated way to know which other services would be impacted by this change. And you can actually force that in the CI/CD. So you can't introduce breaking changes without updating first the clients. So we were able to offer very like a 360 experience for those microservices. And what I really find like the extra to it is that not just you would get those services, but it would be kind of, you would have a direction to a good pattern, right? You would be directed to have idempotent operations. You would be directed to not do dual writes. You would be directed to have monitoring in your microservices in a way that it survives rolling restarts, making things as stateless as possible on the microservices, like maybe only depending on one database and avoiding other data stores and many other patterns. So that's basically it about the microservices. I'm really happy, like, if you want to dive into any of those to get more context for you people. But this is the gist of it. And we still have time for QA. So thanks so much for listening. If something was not clear, please just shoot a question.
Thank you, Renato. I think this was great. It's the first time that we're using Miro for a talk. I think it works really well. It's very organic. So yeah, despite the 10 minutes delay at the beginning, we still got about 9 minutes. So don't be shy, everyone, and feel free to ask questions. Also, I guess, Renato, you'd also be happy to answer anything gorgeous related to the level of detail that you can go into, I guess.
Yeah, absolutely. Is that the moment I can do a hiring pitch?
Always feel free.
Okay, so if you really like a microservices architecture, then Momentive is a great place to join. They're a bit more mature in that aspect. But on Gorgias, we are doing some of those transformations right now. And if you're interested to work with me on my team, yes, totally hiring. So if you find me on LinkedIn, you can follow the links to the Gorgias page to the jobs we have. A lot of interesting challenges, that's for sure. And a lot of fun as well.
Yeah, and I'll link to your contact as well in the follow-up email so people can find you that way. And if you want to shoot me that link with the open positions that you all have, also happy to include it, no problem. Yeah,
we'll send it to you for sure.
Awesome. Cool. All right, well, we have a couple of minutes left. So I see that basically everyone just stayed until the end, which is great to see. So we'll give people a couple more minutes, just if you have any questions that you want to ask. I also remember, Renato, I think we did a quick AMA session on the platform engineering Slack, right?
Yes.
Thanks, David. So I don't know if there were any questions that popped up there that maybe you want to address now while we wait. Otherwise, I also want to point people to your platform con talk. So if you want to spend a couple minutes on that as well. So for those of you who haven't seen it yet, within our community, we've launched Platform Con, which is going to happen the 9th and 10th of June. All platform practitioners like Renato, and I think we have at this point 60, 70. speaker. So yeah, check it out. Renato will speak there as well. And we got a question by Arno. So is there any monitoring on the message brokers you're using? How do you keep track, debug, etc.?
Yes, so it's a very good question. So the reality is, when we first started with this, like almost 5 years ago now, we didn't have a lot of distributed tracing options, right? I would say the de facto option today would be a good distributed tracing system where you can, all the way from the request, kind of generate a request ID, like a span ID, and then a traffic through your whole architecture all the way to the end. But we did introduce headers. So those Outbox, the CAP layer, the HTTP processor pipeline layer, they would automatically add headers to those Kafka messages that could help you to know exactly which step of the way things went wrong, what was the error message, and etc. And we even baked in error paths to those systems. So like, let's say if you could configure a back off retry for some messages, you could say like, hey, if I fail to send this request, it's okay to completely block the pipeline and things like that. So yes, it was a bit rudimentary, but we introduced headers. I would say if you're doing this today, look for a suitable distributed tracing solution for your tech stack that can really go lengths. And the other thing is we had a sweet way to test things because microservices this way, they only depend on data from Kafka and a database to operate. So when you have a local development, you could basically copy data from staging and then feed your microservice locally without having to bootstrap the whole architecture. So that was very handy as well in terms of debugging. And the platform team offered you like easy ways to do that. Like you would have a command in your local development that would simply hook up your environment to staging and automatically copy data for you, and then do all the shenanigans to make it work. Does that answer your question? And if you folks are like curious about anything more specifically, I'm also happy to dive in. As for my platform con talk, like if you can say like what are the most interesting parts of this talk as well, I can also bring it to the platform con talk as well. So like what sparks your eyes in terms of like interesting patterns. And from the AMA that I did last week, I think a lot of people really got into this Outbox pattern. Like this is a topic that, yeah, it's such an invisible problem that a lot of times we don't pay attention to, but every time I speak to someone about Outbox, people get interested. So if there is a couple of outcomes for today, I would say take a look at the base systems, understanding the like what makes a eventual consistent system, and the Outbox pattern. I would say those are very, this is like robust concepts that are really gonna up the game when it comes to message-based microservices. Exactly, you do. So the question is, you create with this pattern, you create duplicate data, but then you gain on autonomous. Yes, exactly. You basically have those local caches for each microservice, which are duplications of the data. Not necessarily though, it's the full data, because sometimes the microservice only depends on a subset of that information. So I don't need like, let's say, the full profile of a user. I only need like 4 fields. So I can choose to only project those 4 fields on my local projection. And as I mentioned as well pretty quickly, like you can also change the read patterns of that cache. So you can make it more optimal for your, for that microservice more specifically. So indeed, you gain a lot of in, yeah, autonomous side. Yeah, you really can reduce single point of failures. And that's, yeah, that's, I think I'm not a, we had an architect, Rafael, that actually helped me with this part of the talk as well on the diagram. So thanks for that. But I'm not the architect myself, but I would say the benefits of having a good eye to eliminate single point of failures is a very important process in the microservices. Yes, there is a Slack channel. Luca can share it with you. So the Humanitech folks, they actually have a platform engineering Slack dedicated channel. So like all the best topics can be discussed there, all the way from platform, systems design, and things like that. So yeah, we can share it with you. And yes, you gain a lot of speed as well, because now like making a database select can be in orders of magnitude faster than making an HTTP call, even if it's within the same network, plus the processing of the other service. So we are talking about like maybe from 50 to 2 milliseconds difference, depending on the use case, of course. And I think we're at time. So, oh, one last one. Let's see. Was your goal to... Yes. Was your goal to remove duplicated data from the monolith? Yes. You eventually, I think you want to do the source of truth switch, right? Which is the cutoff. You sync the data. Now you have a full replica on your microservice where you can read. You still write to the monolith, but then at the API point, you can do the switch to fully start writing to the new microservice, and then either you have stale data on the monolith or you can completely eliminate it. But usually the challenge here is that if your monolith has a lot of join queries that are still depending on that data, you have to move everything before you can actually delete any data from your monolith. That's a complicated process, case by case for sure. We didn't do the pull the switch, no. We did move the functionality away, and then I enhanced that functionality in the new microservices, but we didn't have to do the hard cutoff, basically. You can still achieve that by basically like starting a new life on the new microservice. Now, this won't work if what you're trying to move is so embedded into the monolith, right? That I like to say, every monolith has one table that is used by 30 parts of the system. So I wouldn't start there. That would be very complicated. I would start with the most isolated one. So then you can create a new life for that bounded context, right? For that small boundary you have in your architecture, basically. So.
Awesome. Thank you so much, Renato, for doing this. Thanks everyone for the patience at the beginning.
Yes.
Yeah, stuff happens, but you all stayed until the end, so appreciate it. And yeah, we'll follow up with everything. I dropped the link in there. I'll send a few more links that are useful in the email, including the stuff that you can send me over, Renato.
Yes.
And I hope I'll see you at the next meetup, everyone. Have a good day, evening, wherever you are. And
thanks so much
again,
for
Renato.
joining, everyone. Yeah, it's super nice to have you here, and thanks for sticking to the end. I hope you got something out of it, and see you on the social networks if you guys have any questions, and on the Slack channel as well.
Awesome. Bye, everyone.
Bye.
Have a good one.